The highlights of today's defense news, 26th of May 25. DRDO's innovative system enables Indian Army T-90 tanks for hour-long underwater operational capability, thus boosting border defense. Nibe secures 150 crore rupee defense order from Israeli-based OEM. India and Russia begin talks on advanced BrahMos production. In Operation Sindoor, artillery firepower played a key role in hitting terror targets. Mahindra Defence System unveils new 4x4 bulletproof vehicle based on the Ford F Series heavy-duty chassis. Centre is open to considering Andhra Pradesh for TEJAS expansion plans. Pakistan's mass destruction weapons mentioned in US threat report and China. Indian Air Force aims to dominate near space. How Earth's secret zone could make India unbeatable in the skies. Bangalore-based SpaceTech startup poised to revolutionize global space industry. ADTL Surya VHF radar development, advanced anti-stealth technology for the Air Force. Big Bang Boom Solutions delivers first batch of counter-unmanned aircraft system to the Air Force. Samtel Avionics partner with Royal Malaysian Air Force for Su-30 MKM aircraft. Baba Kalyani champions vital private-public academic synergy for indigenous aero engines, crucial in achieving true self-reliance. 2 Army Brigade set up, mobile network established to boost security in terror-hit J&K's Kathua. Star missile enters final testing stage in India's DRDO program. GRSE becomes L1 bidder for 25,000 crore order from Indian Navy. Pune-based Stats develops comprehensive diagnosis system for aerogas turbine engines. Now let's have a look at the news in detail. India's T-90 Bhishma tanks have been upgraded with a groundbreaking capability, allowing them to operate underwater for up to 1 hour. Developed by DRDO, this system ensures that tanks' crews remains fully operational even when submerged, significantly enhancing India's border defense capabilities. The upgrade is particularly valuable for river crossings, a crucial requirement along India's borders with Pakistan and China. The Indian Army operates over 1100 T-90 tanks, and this new system enables them to navigate water obstacles without compromising crew safety or combat readiness. The DRDO's individual underwater breathing apparatus further enhances survivability, providing 60 minutes of breathable oxygen for tank crews during deep fording operations. This technology has undergone rigorous testing and is now being integrated into the Army's armored fleet. Nibe Limited has announced an international order win worth 150 crore rupees from a leading Israeli-based OEM for the manufacturing and supply of universal rocket launchers with a range of up to 300 kilometers. The contract is expected to be executed by or before November 27. Now let's talk a little bit about what are universal rocket launchers. They are versatile, multi-purpose weapon systems designed to fire different types of rockets and missiles from a single platform. They are engineered for flexibility, allowing armed forces to adapt payloads based on mission requirements. Some of the applications of these launchers: military operations used for long-range precision strikes, area suppression, and anti-armor engagements. For border defense, help secure strategic locations by providing rapid response firepower. In the naval warfare, they can be mounted on warships for coastal defense and offensive operations. For airborne deployment, some systems are integrated into aircraft for air-to-ground missile strikes. In drone integration, advanced launchers can deploy loitering munitions like Sky Striker drones for reconnaissance and precision targeting. For counter-terrorism, used in urban warfare to neutralize threats with high-precision guided rockets. One notable example is the Pulse, that is the precise and universal launching system developed by Elbit Systems in Israel. It can fire multiple types of rockets with a maximum range of 300 kilometers. Amid the successful deployment of BrahMos missiles during Operation Sindoor and strikes on terror infrastructure in Pakistan and Pakistan-occupied Kashmir to avenge the Pahalgam terror attack, India and Russia have opened negotiations to jointly manufacture an advanced version of the BrahMos missile. Russia has extended full technical support to India for the project, and initial talks between the two have already taken place. The newly inaugurated BrahMos facility in Uttar Pradesh, established at a cost of 300 crore rupees, has been identified for producing this upgraded version in significant numbers. Mahindra Defence Systems has unveiled a new 4x4 bulletproof platform designed for military and paramilitary use. This vehicle is notable for being based on the Ford F Series heavy-duty chassis, which is recognized for its robustness and reliability in demanding environments. The vehicle is engineered to provide ballistic protection, making it suitable for high-risk operations and patrol missions. The exact level of ballistic protection is not specified in the available sources, but Mahindra's previous bulletproof vehicles offer protection against the 7.62 mm rounds and are designed to withstand threats such as IEDs and mines. The platform can be equipped with remote weapon stations, automatic grenade launchers, and anti-tank guided missiles, enhancing its combat versatility. Andhra Pradesh Chief Minister has advocated a series of defense related investments in the state as part of a broader push for industrial development. One of the main proposals presented was the expansion of Hindustan Aeronautics TEJAS manufacturing capability into Andhra Pradesh. Currently, the Hindustan Aeronautics operates three TEJAS production lines, two in Bangalore and one in Nasik, which are sufficient to meet current requirements. Andhra Pradesh's request could be considered if future expansion becomes necessary, suggesting that the centre is open to exploring the idea as part of its long-term defence planning. While the centre has not made any immediate commitments regarding the Tejas expansion, it has shown more concrete interest in another proposal, that is, increased capital investment in Bharat Electronics Defence Systems Integration Complex in Anantapur, Andhra Pradesh. This project is slated to be developed in two phases. Phase 1 has already received board approval and is underway, while Phase 2 has received an in principle nod with execution to begin after the completion of the first phase. Indian Air Force is making a strategic leap by expanding its operational focus into near space, the atmospheric region between 20 and 100 kilometers above Earth, often called the ignored middle. This zone sits above the reach of conventional aircraft and below satellite orbits, providing a unique and largely untapped domain for military applications. Near space offers significant advantages for intelligence, surveillance, and reconnaissance, as well as communication. Platforms such as high altitude pseudo satellites and stratospheric balloons can operate persistently at altitudes above 52,000 feet for extended periods, often powered by solar energy. New Space Research and Technologies has marked a significant milestone in India's pursuit of advanced aerial surveillance and communication capabilities with the successful flight of its solar powered high altitude pseudo satellite prototype, which achieved a continuous flight duration exceeding 21 hours during a rigorous winter solstice trial, a period known for minimal sunlight and challenging atmospheric conditions. The Air Force's near space platforms are deal for ISR and also serve as airborne data relays, addressing India's communication challenges across its diverse and challenging topography. By acting as relay nodes, these systems enable seamless real-time communication between air, ground, and naval forces, thus supporting network-centric warfare and enhancing operational coordination. Further, near-space assets play a crucial role in ballistic missile tracking, especially during the mid-course phase, providing vital data for missile defense systems. To realize its near space ambitions, the Air Force is collaborating with ISRO, DRDO, private firms, and academic institutions. The IDEX initiative is also supporting the development of disruptive military technologies, with the Air Force playing a central role in ensuring these technologies meet operational needs. Alpha Design Technologies has achieved a significant milestone in India's indigenous radar development program through its creation of the Surya VHF radar system for the Air Force. This cutting-edge radar technology represents a substantial advancement in India's capability to detect and track stealth aircraft, addressing critical gaps in the nation's air defense infrastructure. The Surya VHF radar system represents a technological leap in India's radar capabilities, operating within the very high frequency band of 30 to 300 MHz, which provides distinctive advantages for detecting low observable aircraft. The system is characterized by its impressive range capabilities, with confirmed detection distances of up to 400 kilometers for low radar cross-section platforms, making it one of the most capable truck-based mobile VHF radar systems in its class. The radar employs advanced 3D surveillance technology, providing complete 360-degree coverage with detection altitudes reaching up to 15 kilometers. The technical architecture of the Surya radar incorporates state-of-the-art solid-state transmit-receive modules, which are fundamental to the system's signal processing capabilities. The signals received by each transmit-receive module undergo processing by digital signal processors located at the rear of the radar antenna, with the processed information subsequently transferred to the control cabin for comprehensive analysis. This sophisticated signal processing architecture ensures high precision tracking and accurate identification of aerial threats even in challenging electromagnetic environments. The mobility aspect of the Surya radar system is achieved through its deployment on two specialized 6x6 trucks, with one vehicle dedicated to housing the radar antenna and the other accommodating the operator station, uninterruptible power supply for both vehicles, and identification friend or foe antenna. Alternative configurations utilize Tatra vehicles, which enhance the radar's strategic mobility and allow for rapid deployment across diverse operational environments. Indian Air Force has contracted for 6 VHF radar units from Alpha Design Technologies, with the first unit scheduled for delivery by mid-March of 25. India's Star missile project has entered phase 3 development as DRDO engineers conduct full system integration and advanced validation trials. Phase 3 in missile development focuses on system validation through extensive flight testing. Engineers integrate all subsystems, including propulsion, guidance, and control, into a full-scale prototype. The missile undergoes multiple live trials under simulated combat conditions to evaluate accuracy, reliability, and overall performance. Data collected from these tests help the team fine-tune the design and ensure the missile meets operational requirements before entering production. The Star missile travels at over Mach 2.5, matching the speed of modern anti-ship cruise and standoff weapons. It performs sharp maneuvers and rapid altitude changes, forcing operators to use advanced tracking and engagement systems under pressure. This simulative environment prepares defense units to react quickly against time-sensitive threats in future high-stake combat scenarios. DRDO is developing an air-launched Star version for fighter platforms such as LCA TEJAS for air-to-air and air-to-ground combat roles. These versions may support anti-radiation and anti-AWACS missions by offering target realism and engagement readiness at tactical range. Airborne deployment expands STAR's reach and utility during joint force deployment like Operation Sindoor and rapid response simulations. Adding booster stages enables STAR to launch from ground vehicles or static platforms for strike training and longer endurance. The ground-based version serves as a versatile tool in simulating surface-to-surface or shore-to-ship supersonic missile engagements. The commanders can deploy STAR across rugged or remote locations without expensive setup or launch infrastructure. The STAR missile uses a liquid fuel ramjet engine that breathes atmospheric air during flight for sustained high-speed travel. This design reduces internal fuel load, lowers weight, and increases flight duration without compromising speed or maneuverability. DRDO engineers selected this technology to maximize performance and minimize system complexity during repeated field testing. STAR also acts as a live test platform for DRDO's ramjet engine programs and future missile propulsion development efforts. Technologies validated on STAR feed into other systems like the AWAC killers, tactical anti-radiation missiles, and low-cost fast cruise missiles, boosting India's high-speed missile capabilities. This shared innovation approach shortens development cycles and reduces risk for operational next-generation missile projects. GRSE has emerged as the lowest bidder L1 for the Indian Navy's next generation corvette project valued at 25,000 crore rupees. The key details of this contract: GRSE will construct 5 advanced warships for the Navy. Corvettes will be equipped for surface-to-surface missile strikes, anti-missile defense, anti-submarine warfare, and maritime strike missions. The ships will incorporate green warship design principles, focusing on energy efficiency and environmental sustainability. The contract was awarded under a competitive bidding process, strengthening GRSE's position in India's defense shipbuilding sector. So how will this impact GRSE? GRSE's order book has significantly expanded, reinforcing its role as a key defense shipbuilder. The company's stock price surged following the announcement, reflecting investor confidence in its capabilities. The first phase of design finalization and procurement is expected to begin within 6 months, with revenue recognition projected from 2027. GStats Labs Private Limited, Pune, in collaboration with DRDO and GTRE, has developed an AI/ML powered diagnostic system for aero gas turbine engines. This system leverages virtual sensors and digital twin technology to enable real-time health monitoring and operational assessments for military and civilian applications. It enhances engine reliability, performance, and efficiency, benefiting both aerospace and energy sectors. The project underscores India's growing synergy between defense research and private industry, driving technological innovation in aerospace engineering. That's all the news for today. We hope you enjoyed the news. Please do subscribe to our channel and do give us your feedback. Thank you and have a great week ahead.